Okay, so this is now the third instalment of our kind of journey into programmable systems and what they look like in National 5 Engineering Science. So what we've got here is the end of that previous exercise from the second video, where we've got a specification up here. The bulb's going for 1 second, blah blah blah. And these were the questions where the microcontroller is only controlling inputs. Notice there are no outputs, no inputs attached to the microcontroller. The microcontroller is just being programmed with a set of instructions, and it's just doing that job. It doesn't require any information from the real world in order to do its job. And this is what the last one looks like. So you can see here it's got turning the bulb on, in line with the specification up here. It turns the bulb on, waits half a second, turns it off, waits a second, and then continually cycles between the motor and the solenoid with a frequency of 2 seconds. There's no stop bubble in this one. The other two of the other ones require stop bubbles. These two, this one here and this problem here, require loops. The loop in that one is the entire flowchart, whereas in this one it's only a part of the flowchart that's been looped. What we're going to do now is we're going to look at, we're going to stick with systems that don't require any inputs. But rather than doing something only once and then the microcontroller is useless until you unplug it and plug it back in, or having a system where the same thing happens over and over again forever, I'm going to show you how to make a system where a thing happens for a really particular amount of time. And what I want you to notice is that just like I can choose a part of my flowchart to loop forever, I'll be able to choose a part of my flowchart to do it a certain number of times. We call this a finite loop. It's like the opposite of infinite. And infinite is a number that's so big it doesn't value it. Finite is a number that we can put a value on and understand it and count it. So yeah, like for instance, let's do this 3 times or let's do this 5 times. So what I'm going to do is I'll set up a problem and kind of talk you through it. Right? Give me a wee second. Okay, so let's actually build this problem together then. So we've got our 18M2, a red light is to light for 0.7 seconds, then go off for 0.7 seconds, and that's to happen 4 times, so the light's to flash 4 times, right? So we put an LED on the output. It doesn't tell us what pin, so I'm just going to choose one. I'll choose pin 3, I can stick a 0 volts line on there. That's the symbol that we use for 0 volts, essentially our reference. I could put 0 at the bottom, or I could put my 5 volt supply at the top. I'm going to put a light emitting diode in. We double click it, make sure it's red. It is red. You can change the colour, red, green, yellow, blue. And then I'm going to put a resistor in series with it, because we always use a resistor in series with a diode, a light emitting diode, because light emitting diodes are so low resistance that if we were allowed to put any more than maybe 1 or 2 volts across it, the light emitting diode would just get destroyed. So that's me got the technology of my system set up. I've got a bipolar junction transistor in there, NPN transistor in there as a transducer driver, okay, to make sure that the LED gets just as much energy as it needs to do its job. So let's actually build the flowchart. So I'm going to go start. The LED is to come on, it's on pin 3, so I'm going to want set outputs, pin 3 on, 0.7 seconds is a delay, and then want pin 3 off, another 0.7. Now I suppose this is to do this 4 times. If they ask you this in the SQA, you could just, draw that 4 times and it would do the same job, right? But you're not learning about loops, and there are other things where you wouldn't be able to do that if the loop was too big. If you were asked to do a massive bit of code 4 times, the last thing you would want to do is have to write that out 4 times. You might find a way of just writing it out, telling you how to do it 4 times. That's your core piece of programming that's to happen 4 times. How are we going to make it happen 4 times? We're going to use a counter and a decision symbol. Microcontrollers, different microcontrollers have different amounts of memory. This microcontroller's got a small amount of memory that we can use. It's got little boxes that we can store numbers in, and the boxes have names. The boxes are named B0, B1, B2, B3, B4. As long as we use that nomenclature, as long as we use those names, we can ask the microcontroller to remember things for us and remember it in there. We can only ask it to remember numbers, right? So what I can say is in here somewhere there will be a set variable. right? That's setting one of these values. So I can say set, it calls it x, but I know it's called b0, right? So set x to 0. Let's do that before we do our code. So before we do anything, let's put a number into memory. Let's run our functional code. Let's turn it on, wait 0.7 seconds, turn it off, wait 0.7 seconds. And then let's add 1 to our value. Now all that's important about this loop is that whatever it says here, set x to 0, it adds 1 to the same thing. I could change that to say anything. Set Superman to 0, add 1 to Superman, and this system will still work. There are some protected things that you can't put in there. You couldn't put high, low, you couldn't put start or stop or end, or protected code words. So you can put words that aren't code in there. So this is me addressing those wee memory locations. I'm asking the microcontroller to remember a value called 0, and I'm giving that value a location that I'll remember its name. So I've put 0 into Superman. Giving it a daft name like that maybe doesn't help. Maybe we should call it LED counter. Yeah, that'll help us, right? If we had a big bit of code, the last thing we would want is to have daft names and we don't know what those memory locations are actually holding on to. So you give those memory locations meaningful names. So set LED counter to 0. Count it. Run the code, sorry. Add 1 to your LED counter. So that's now 1. And then we've got a wee decision symbol here. What's that? It says test input. I don't want that one. What does that one say? Test variable. LED counter is a variable. So I can test LED counter to see what value it is. And I only care about 4. I don't care if it's 1, I don't care if it's 2, I don't care if it's 3. If it's not 4, I run again. If it is 4, I'm finished. And that's my code. So when you see a flowchart that's running a finite loop, what you've got in here is your functional bit. That's the thing that's getting done a certain number of times, and all these other things are just there to create that counted loop, to create that finite loop. Set a counter to 0, run our code, increment the counter, that means add 1, and then check to see if we're at our target value yet. So now if I run this, hopefully that LED will go on and off 4 times. 1, 2, 3, 4, and then it stops. This is a finite loop. Okay, so I've added another problem in here. So what we've got is a microcontroller with 2 LEDs on it. This one is a green, see in the second line there, green 3mm. Green LED attached to output 0, and then that one is a yellow 3mm attached to pin 5. And the problem says a green LED attached to output 0 is to flash 6 times, and each flash is to last 2 seconds. Then a yellow LED attached to pin 5 is to flash 5 times. Each flash is to last 1 second. Now, see that bit about each flash is to last? See if we look back at the previous example, there's a flash, on and off is a flash. And that on-off flash lasts for 0.7 in the first half, 0.7 in the second half. So each flash in this one was 1.4 seconds. That's 2 0.7s added up. So over here, when you're doing your functional wee bit of code here for the green LED to flash just 1 time, then there's to be a wait after the on and a wait after the off, and those 2 waits have to add up to 2 seconds. If you want them equal, it would be 1 and 1. It doesn't tell you in here that it has to be equal. It just says that each flash is to last for 2 seconds. I would do 1 and 1 though, I wouldn't play games. And it's the same for the yellow, each flash is to last 1 second, so that means that the 2 delays have to add up to 1. So it would be 0.5 and 0.5. And there's 2 different sets of loops in there. So basically you would have a start bubble, a counter set to 0, a bit of functional code, adding 1 to a counter, and then a test loop back here. And that would be what you would do to detect the green LED flashing 6 times. Once the answer was yes, once the green LED had flashed 6 times, then it doesn't go to a stop yet. It goes on to do exactly the same bit. So, a double length bit of flowchart here for the green LED. But in each case, that target value and a decision symbol is going to be different. Remember, that's the number there, that controls how many times the light flashes. If I want it to flash 3 times, I change that number. If you're doing this on Yanka, kind of handy. You can cut and paste. And all you're doing is changing the values in the flowcharts, because the shape of the code is the same, you're just doing it twice. I'm going to set up another one. So this is I'll only put one more in this, and this will be a wee problem for yourself. Right, okay, so last problem in here then. So the last problem is it's very heavily based on the previous circuit, so you should be able to cut and paste quite a lot of the flowchart content. I've added another output device, I've added a motor in. In fact, I'll need to make sure that that's a, oh, it's a tip 31, that's fine. So I've added another output device, a motor, and it's connected to pin 3. So it says the motor has to come on first on its own. A second later, the flashing routines begin. And then after our flashing routines are finished, the motor then switches on and off for a second every time, on for a second, off for a second, on for a second, off for a second, forever. So what we've got is a finite loop to count these guys, and then an infinite loop to leave the motor running forever. Give that your best shot. What I'm going to do is I'll save this as, rather than microcontroller simple problems, this will be saved as just microcontroller problems in the same place as your previous file. Right, okay. Remember, once you complete that, make sure your teacher sees those 2 flowcharts built or written down. You can write these down. Problem with writing them down is you can't test them. So you're better to do it in Yanka.